Hello students, welcome you all in today's video. Today we are going to discuss about the velocity of electron in an orbit. In the previous video I discussed about the applications of the Bohr's atomic model. Although this video became little lengthy because in the beginning I started discussions about the postulates of the Bohr's atomic model as well as its limitation to make it easy for you. Now I try to make this video as short as possible, so listen carefully. Let's start. Velocity of electron in an orbit. When I say the velocity of electron in an orbit, my dear student, it means only the velocity of electron that are revolving in the hydrogen atom or hydrogen-like species, because we are discussing only about the hydrogen and hydrogen-like species, and this Bohr's atomic model is not valid for the multi-electron species. So velocity of electron can be calculated by V, n, where n is the orbit number. 2 pi k, k is a proportionality constant, z is the atomic number, E is the electron charge, E square upon nh. You know what is h? H is the Planck's constant. But some of you are thinking, sir, this formula is so complex. How can you remember this formula? But you are here. I make you remember this, and this is the simplest way to learn the chemistry here. I am going to put the values of all the constant and giving you the simplified version of this formula, where this formula you have to remember. Why? I'm just n and z. This value will change, where pi, k, e and h remain constant. I put all the values of these constant, and finally what I get is velocity of electron in nth orbit is equal to 2.18. 2.18 into 10 to the power 6 into z by n, where z is the atomic number. If it is hydrogen like species, you have to put the atomic number. If it is only hydrogen, then we have to put 1 here, because the atomic number of hydrogen is 1. And n is the orbit number. N is the orbit number. If it is first orbit, you will put 1. If it is second orbit, you will put 2, and so on. Okay, remember this formula, velocity of electron in an orbit. And from this formula, my dear student, I think you can conclude that the velocity of electron in nth orbit is inversely proportional to the orbit number. What does it mean? It means velocity decreases as we move away from the nucleus. The velocity of electron that is revolving in the first orbit will be maximum, while the velocity of electron that is revolving in the last or far away orbit will be minimum. So velocity of the first orbit will be maximum, then velocity of second orbit, then velocity of third orbit, and so on. Okay? And you know what is kinetic energy? The energy due to the motion of the electron. If the velocity is high, and you know the formula, velocity kinetic energy is calculated by half mv square. So you can say, sir, if the velocity is high, the kinetic energy will also be high. These two important relations are asked in 2020 and 23 JEE examination. What is the relation between the velocity and kinetic energy if the electron is revolving in a particular orbit? Remember these two relations. Kinetic energy of the first orbit is maximum, then kinetic energy of the second, third, and so on. Okay? And just like the velocity radius, in examination they may ask to calculate the ratio of the velocity of the two orbits. So my dear student, you can use this formula, you can take the screenshot, relation between the velocity and the orbit number. If they ask the velocity ratio of the two different orbit, you can write v1 upon v2, that is the velocity of the given orbit, velocity will be given, or the orbit number will be given. v1 upon v2 is equal to n2 upon n1. Why? Because velocity and the orbit number are inversely proportional to each other. And also, if they ask to calculate, although this is rare chance of this formula, in JEE Advanced they may ask this. Time period of electron Tn is directly proportional to n cube upon z square. This relation is asked in, as far as I remember, 2024 and other central CUET examination. So just directly you can remember this formula. Time period of electron is equal to n cube upon z square. From where these are coming? These are lengthy calculations. We are avoiding these calculations. Just our target is to qualify the examination and book the seats. You must get a particular one seat in the examination, not to learn all the things. Someone you must have to guide what to learn and what not to learn, and I am here to help you. Trust me and learn. Okay, then after you can take this screenshot. This is the important formula. And the last concept, although it is very rare, the number of revolution per second, that is frequency or the angular frequency, is calculated by v is equal to, v is the velocity, 6.6 into 10 to the power 15 z square upon n cube, z square upon n cube. And here the time period is n cube upon z square, opposite. And my dear student, angular frequency 1 upon n cube. We can write angular frequency is inversely proportional to 1 upon n cube. Why I am writing this formula? Because this question directly asked. You can cross check in other examination, previous year question paper. They are asking what is the relation between the angular frequency and the orbit number. So this is important. I derived this conclusion from the formula that I already explained to you. This is the brief about the velocity of electron in an orbit of hydrogen and a hydrogen-like species. This is all about the velocity of electron in an orbit. We'll meet you in the next video with the energy of electron in an orbit, how to calculate the energy of electron in an orbit. Thank you so much for watching this video. We'll meet you in the next video. Take care. Bye-bye.